So now we're up to Chapter 4, Lesson 7, and it's on scientific notation. Now, scientific notation is really useful when you're representing either really small or really large numbers. And the easiest way to recognize this is going to be by seeing the examples. And this is how a number is written when it's in scientific notation. That is the representation of this number here, 6,000. And one way of thinking about it is in terms of 6,000, I'm going to write this out a little bit bigger over here. 6,000. Okay. You need to change that number into a number that is less than 10 but greater than 1, so it's going to be 6.0. That's the only number that you can use. If you move over the decimal place, you go 1, 2, 3 spaces over, and you're left with the decimal being there, so it's going to be 6.0 times 10 to the however many decimal places you moved over. You moved 1, 2, 3 spaces over. So that's the way it works. And an easy way of thinking about this is that when you're multiplying, when you're changing it and you have a number that's greater than 0, you're moving the decimal points 3 spaces, so that's the reason why it's 3 here. So it's 1, 2, 3 spaces, and so it's a 3 there. So here, what's happening is you're changing a number that's really small into scientific notation, but you've got to use negative exponents. So this is the standard form, and then this is going to be what's called the product form, which is just 1.7 times 0.000001. I believe that's the right amount of zeros. But same sort of idea here. I'm going to rewrite it up here. So that's 1, 2, 1, 2, 3, 4, 5, 6 zeros total. So that's 6 zeros total, and it's like that. I believe that's the right amount of zeros. Okay, and so you're changing it, and the first part is you need to move over the decimal point a bunch of places until you end up with a number that is between 10 and 1. It needs to be between 10 and 1. So here, 1, 2, 3, 4, 5, 6. If you look there, 1.7 is the first number that's between 10 and 1. And then it's going to be, you move the decimal point over 6 spaces, but you moved it to the right. So it's going to be to the negative 6th power. So let's look at a couple more of these. I'm going to look at a couple more of these down here. So write this number in scientific notation. I'm going to rewrite it up here. 0.0000. So there's 4 zeros there. 5, 2, 3. So I'm going to move the decimal point over 1, 2, 3, 4, 5. 5 spaces over. So it's 5.23 times 10 to the, I moved it 5 spaces to the right, so it's going to be to the negative 5th power. For this one here, it's going to be 81200. And so 81,200. I got my decimal point is there, I just don't see it. So I go 1, 2, 3, 4 spaces over. So it's now going to be 8.12 times 10 to the 4th. If you want to do the 10 to the 4th part first, that's fine because you're moving it over. And if you don't want to forget that, that's fine. For this one here, it's going to be 985,000. 000. Again, my decimal point is here. I just don't see it, so I'm moving over 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 spaces. So 10 to the 8th. And then it's going to be 9.85 times 10 to the 8th. So that's how this works. And I'll do that last one, 0.001289, and I have to stop when I go 1, 2, 3, 4. I have to stop at that point because 1.289 is between 1 and 10. So it's going to be 1.289 times 10 to the, and I moved over 1, 2, 3, 4, 4 spaces to the right. So it's like that. So here's another example. It says here, write 1.15 times 10 to the fifth in scientific notation. So what you're going to do is 1.15, just add a bunch of zeros, and then move the decimal point over 5 spaces. 1, 2, 3, 4, 5. So then you can get rid of these extra zeros, and you're left with, I'll just rewrite it, 115,000. So that's 115,000. So same sort of thing here. If you write it in standard form, you're going to go ahead and move the decimal point over. In this case here, you're going to do it, put a bunch of zeros in front. So it's 7.63. Put a bunch of zeros this way because you have a negative exponent. And then you're going to move it 8 spaces over. So 1, 2, 3, 4, 5, 6, 7, 8. And you'll need an extra 0 there. So that's what it's going to look like in terms of if you're going to move it over 8 spaces. And so that's the equivalent of that right there. So let's look at this example here. 5.7 times 10 to the negative 7th power. So 5.7, 1, 2, 3, 4, 5, 6, 7. Just put a bunch there. So I'm going to move it over to the negative 7th power. So I'm moving it over 1, 2, 3, 4, 5, 6, 7. So it's going to be 0.000 0, so 1, 2, 3, 4, 5, 6, 0057. That's in standard form. So really, scientific notation is all about just moving decimal points and counting the amount of spaces that you move. And if you move the decimal point to the left, when you're going from scientific notation to standard form, then basically, if you're moving it to the left, that's because it's a negative exponent. If you're moving it to the right, then it's because it's a positive exponent. So for this one here, let me clear this off. This problem here, it's going to be 3, actually I have it right over here, 3.524. Put a bunch of zeros here right on this side. And now I got to move over the decimal point 5 spaces. 1, 2, 3, 4, 5. So that's where it's going to be. It's going to be 0.000035524. That's it in standard form. 3524. Sorry for my handwriting there. So for this one here, it's just going to be 1.04. Put a few zeros over here. Move the decimal point 2 spaces to the right because it's, or 3 spaces to the right because it's positive. So 1, 2, 3. So my final answer is going to actually be 1,040. Because I don't have to worry about the extra zeros there. Just my decimal point is going to be right there. And for this one here, 1.24. Add a bunch of zeros, like I said. Move it over 6 spaces. 1, 2, 3, 4, 5, 6. Get rid of that 0. And your final answer is going to be 1, 2, 4. And then 4 zeros. 1, 2, 3, 4. So that's going to be the final answer there. Very quickly here, if you're ordering numbers like this, easiest way to recognize this is to understand if they're written correctly in scientific notation, is just to see which actual power it is. So in this case here, definitely this one's going to be a bigger power, or a bigger number, because if it's written correctly in scientific notation, then it is a power to 10 higher. So it's going to be one more decimal place over. The 8,900,000 we have to actually figure out. So 8,900,000. So if you wanted to, 8,900,000. So it's there. I have one too many zeros, so let me get rid of that. So 8,900,000 900,000. So I'm going to put this in scientific notation so to be able to compare them. So 1, 2, 3, 4, 5, 6. And when you go ahead and do that, that's going to be 8.9 times 10 to the 6th power. So this one here is going to be the biggest number. And then 8.9 to the 6th power is going to be the second biggest number. So this is going to be 1, 2, and then 3. Or actually, in terms of size, but it says from least to greatest, so we're going to have to reverse that. So this is actually going to be, this is the biggest number, so it's actually going to be in the correct order. It's going to actually be this way. This one here is the smallest number. This one here is the second smallest number, and this one here is the biggest number. So that would be the order in which you'd put them. So in terms of ordering these numbers from least to greatest, same sort of idea here. So we're just going to find the decimal places. So I'm going to do that quickly. So I just rewrote these out. All I did was I counted over decimal places as we did in the previous one. Now I can compare them. Which number is bigger? Well, this number here is the biggest out of them. So let's do this the right way. We're going to try and do it from least to greatest. So if this is this number there, the number that is the smallest number is actually going to be this one here. The number that's second smallest is going to be 1.08, and so they're actually in the right order there. For this other one here, which one is the smallest number? This is the smallest number because it's to the power of 10. That's the smallest, so that's an easy one to check. The second smallest is going to be this one here because 1.03 is smaller than 1.035 when the power is the same, and that's this one here is going to be the biggest. Last couple of things here in terms of multiplying numbers. All you're going to do for this one here is you're going to multiply 1 times 2 times 8.2, whatever that is, and then, so that's part of it, but then it's now going to be 10 to the 9th power times 10 to the 9th power. If you were to write these out in scientific notation, you would then adjust this as needed to put it back into scientific notation. For this one here, because remember in scientific notation, the number that is multiplied by the power of 10 has to be between 1 and 10. So over here, we got 7.2 times that. So it's still going to be 7.2 times 3.6. That's part of it. And then it's going to be negative 2, 10 to the negative 2 power times 10 to the 3rd power. So that's just times 10 to the 1st power because it's 3 minus 2. So 10 to the 1st power. So I'll figure those out and then write them up. So I rewrote these out with the actual answers here. If you see here, this one is fine because 9.84 is still between that number 1 and 10. So that's fine as a part of the scientific notation thing. But this one here is not. So I have to adjust it. That's what 7.2 times 3.6 is. And then when I multiply those two together, I get 25.92. So times 10 to the 1st power, because I got that from the negative 2 plus 3 in terms of those two powers. So now I've got to adjust this so it's in the correct scientific notation form. So it's going to be 2.592 times 10 to the 2nd power because I've got to move over the decimal point one more space in order to be accurately representing scientific notation. Just check that and make sure that makes sense. 7.592. So we'll go over this more in class. Hope this makes sense.